Redox reactions are a little bit more complicated to balance than your standard reactions. And so when we are balancing redox reactions, we balance them using what's called the half reaction method. A oxidation reduction reaction can be broken into two half reactions. One half reaction would represent the reduction process. And in that reaction, because reduction is a gain of electrons, electrons would be reactants. And then the other half reaction would represent the oxidation process. And since oxidation is loss of electrons, the electrons would be products. When we are balancing these, we are going to do so in acidic solution. So solution, of course, indicating that water is present. Acidic, indicating that there's hydrogen ions present. So when we are doing these balancing half reactions, the process is always going to be the same. You're going to identify and write the equations for the oxidation and reduction half reactions. And then for each half reaction, you're going to follow step 2 in order. So first, you'll balance all of the elements except hydrogen and oxygen. Then you balance oxygen using water. You balance hydrogen using hydrogen ions because we're an acid, those hydrogen ions are present. And then you balance the charge using electrons. Then you are going to add your two half reactions together. And before you do that, you need to make sure that the number of electrons on each side will cancel. And so you might need to multiply one or both half reactions by some coefficient so that you have an equal number of electrons on each side and they cancel. Add the half reactions and then just check to make sure that everything balances. So in this oxidation reduction reaction, we're still going to assign our oxidation state so we can see what's going on. So the manganese is a +7, oxygen's a -2, iron's a +2, this iron's a +3, and that manganese is a +2. So the manganese is being reduced. It's going from a +7 to a +2. The iron is being oxidized. It's going from a +2 to a +3. So I'm going to kind of break those two individual reactions out and write them separately. So we have the permanganate ion going to the manganese 2 ion, and we have the iron 2 ion going to the iron 3 ion. Now I'm going to take each half reaction individually and go through those steps. So first I will balance anything that's not oxygen or hydrogen. So I have one manganese on each side, so those balance. Then I will balance the oxygens using water. I have 4 oxygens on my reactant side, so I need to add 4 waters to the product side to make sure there's 4 oxygens on that side. Of course, when I do that, now I've thrown hydrogen in there, so I have to add a hydrogen to the reactant side to balance that out. I have 8 hydrogen on my product side, so I need 8 hydrogen ions on my reactant side. Finally, we balance charge using electrons. So if I were to add up the total charge of this side, manganese is a +2, water is a 0, this side's +2. Total charge of this side, the hydrogen's a +8, because there's 8 of them, each one's a +1. Manganese is a -1, so this side is a +7. They need to be equal charge. So I'm going to add electrons to the reactant side, because electrons are negative. So I'm going to add electrons to the reactant side so that they both have the same charge. So I'll add 5 electrons, because that, of course, would be a -5, and that would bring my total charge down to +2. All right, I'm going to follow the same process for my oxidation half reaction. So first of all, make sure there's the same amount of atoms on each side. There's 1 iron on each side, so we're good there. There's no oxygen to balance, there's no hydrogen to balance, so then I just have to balance charges using electrons. There's a +2 on the reactant side, a +3 on the product side, so I'll add 1 electron to the product side to balance those charges. If you do this correctly, you will always have 1 half reaction where electrons are reactants and 1 half reaction where electrons are products. Now it's time to add these two reactions together, but before I do that, I need to make sure that my number of electrons is going to cancel, and in order to cancel, they have to have the same coefficient. So I'm going to multiply this entire reaction by 5 to get 5 electrons so that they would cancel. So it's going to be 5 iron 2s plus 5 iron 3s plus 5 electrons. So let me just cross that out so I don't get confused. So now I'm going to add those two reactions together. My electrons cancel. I don't have any other species that appear in both, so I'm going to just go ahead and write what's left. So 8 hydrogen ions plus the permanganate ion plus 5 iron 2s. Oh, definitely should be an arrow right there. Goes to the manganese 2 plus 4 water plus 5 iron 3s. So that is my complete balanced oxidation reduction reaction. I should, of course, check that everything balances. So I have 8 hydrogens on each side. Oops. H2O, sorry about that. I have 8 hydrogens on each side. I have 1 manganese on each side. I have 4 oxygens on each side. I have 5 irons on each side, so those balance. Let's check our charges. So this is going to give me a plus 8. Permanganate's a minus 1. This is a plus 10. So I got a plus 17 on my reactant side. This is going to give me a plus 15. This is a 0. This is a plus 2. So that's going to give me a plus 17 on my product side. So the charges balance as well. So let's do another example here. Again, assign oxidation states so I can see what's going on. So my iodine is going from a -1 to a 0. So my iodine is getting oxidized. My chromium is going from a plus 6 to a plus 3. My chromium is getting reduced. Oops. Whoopsie. I will pull those two half reactions out. So iodine goes to I2. And dichromate goes to chromium 3. So to balance my oxidation half reaction, the first thing you need to do is to make sure there's the same amount of atoms on each side. So you balance everything except oxygen and hydrogen first. Of course, oxygen and hydrogen do not appear in that top reaction. But I do have 2 iodines on the product side, so I need 2 iodines on the reactant side. So my reactant side charge is -2. My product side is 0. So I need to add 2 electrons to my product side to balance out the charges. And then that one's all set. For my reduction half reaction, again, I have 2 chromiums on my reactant side. So I need 2 chromiums on my product side. I put a 2 there. Then I balance my oxygens using water. So I need 7 waters because I need 7 oxygens. Then I balance my hydrogens using hydrogen ions. I have 14 hydrogens on the reactant side. So 14 hydrogens on the product side. I have 14 hydrogens on the product side, so 14 hydrogens on the reactant side. Then I have to balance my charges. So this is a plus 14 minus 2. That's going to give me plus 12. This is a plus 6. This is a 0. That's going to give me plus 6. So I need to add 6 electrons to my reactant side to balance charges. All right. Now I just have to add these 2 reactions together. Of course, to do that, I'm going to have to multiply this one by 3 so that I have 6 electrons on either side. So 2 iodine going to I2 plus, 6 iodine, multiply the entire thing by 3, plus 3 I2 plus 6 electrons. So I'll get rid of that. So the electrons cancel. Just go ahead and write what's left. Three iodine, 7 waters. And then, of course, double check. So I have 6 iodines on each side. I have 14 hydrogens on each side. I have 2 chromiums on each side. And I have 7 oxygens on each side. Let's just check our charges really quick. So this side is a plus 6. That's a 0. That's a plus 6. That's a 0. So this side is a plus 6. So the charges work out as well. So I am done.